I can describe the effect a given transformation has on a graph. Here's what you need to know. F of x equals x is the most basic function that we can possibly have that's called the parent function because that's where everything starts. Any other linear function that we have is some sort of transformation of this basic function right here. So any kind of equation that you might have that is linear, that means you have a highest power of 1. It's just a change from plain old x. You're doing something to plain old x. So let's take a look at some of these possible transformations. Right here, if I add something at the end of my equation or the end of my function, that's going to move my graph up that number of units. It also moves your y-intercept up k number of units. And we're going to look at specific examples of all of these in just a second. So if you're not quite with it yet, it's okay. But I encourage you to come back at the end and take another look at this chart just to make sure it's all clicking. You can also subtract something to your function and that would move it down that number of units. You can subtract something with just your x, just your input. That's going to shift your whole graph to the right. It also moves your x-intercept to the right. You can add something to your x value. That's going to shift your graph to the left that number of times. It moves your x-intercept to the left. All of these are called translations. When we're moving along a straight path, either up and down or left and right, that's called a translation. Vertical translations, up and down, go in the direction that the sign tells you to. So right here I had plus k, I go up, minus k, I go down. And your horizontal translations, your left and right ones, they move in the opposite that your sign indicates. So right here, your minus h is actually to the right, and plus h is actually moving your graph to the left. It's the opposite. That one's kind of funky, but you'll be okay. Another type of transformation is multiplying my whole function by something. That's called a vertical stretch when the absolute value of this a right here is greater than 1. It makes my slope steeper. It's called a vertical compression when the absolute value of this a right here is less than 1. So if it's like 1/2 or 3/4 or 5/6 or some sort of fraction value that's smaller than a whole, then that means you have a vertical compression and your slope is going to be less steep. We can also multiply inside the function right here just on the x value. Like we're not multiplying the whole thing, just the x value. Those are called horizontal stretches and compressions. You have a horizontal stretch when the absolute value of a is less than 1 and your slope becomes less steep. And it's a horizontal compression when the absolute value of this number right here is greater than 1. Your slope will become steeper. So just to recap right here, when I'm multiplying, if a is smaller than 0, so if it's a negative number, you're not only stretching or compressing, you're also going to reflect your entire graph across your x-axis. Similarly, right here with this blue one, this a value, if it's negative, you're going to be reflecting your entire graph across your y-axis. Vertical and horizontal translations change the intercepts. Vertical and horizontal stretches and compressions change your slope and the intercepts. Let's take a look at a more specific example and start to make some of these things click. If I have the transformation f of x plus 4, I've got this one right here with the minus 3, a negative 2 out front, and a 1/2 right here. My plain old boring function is this black line right here that you can see. This is f of x. This is just my equation. F of x equals x. That means that my x and my y values are the same in every single location. So like I've got the point 1, 1, 2, 2, 3, 3, and so on. That's the black line right here. It's just your plain old boring function. And we're going to start messing with it. We're going to make some changes or some transformations. And this way you can just visualize what's happening. So let's start with this red one right here. Let's add 4 to the whole thing. So I'm going to shift my graph up 4 units. So if you're just comparing the black one, the starting point, to the red one right here, you can see that all we did is we took this black line and we shifted it straight up 4 units. So that's the type of change that you see right here. This type of equation, minus 3, but it's inside the parentheses, you can see that we are shifting our graph to the right 3 units. So I took my black graph and I pushed it this way. I pushed it to the right 3 spaces to get to this green location right here. My orange one, this is representing a vertical stretch by a factor of 2. My slope is becoming steeper. And I'm also reflecting across the x-axis. Because this is a negative value, I had to flip-flop my line. So you can see that it's now going in a different direction than the original black line. This orange one has flipped or reflected across the x-axis. And then I also stretched it by a factor of 2. I made my line steeper. And the last example, the blue one, this is called a horizontal compression by a factor of 1/2. My slope is becoming less steep. So if you were to compare the black line to the blue line, you can see that the blue one isn't sloping quite as high as the black line. The black line is going up at a bigger angle than the blue one is. Now you pause and try to just describe the effect of the transformations on the graph. Here are all of those graphs together in one place. Again, the black one is the original parent function, and everything else is a transformation. So in this first one right here, and I didn't color code anything because I didn't want you to be looking for that. I wanted to see what you could pick out on your own. You have 2 things going on. You have a vertical stretch by a factor of 3. That's because I'm multiplying my function by 3. And then I'm subtracting 1 from my function. That's going to push the whole thing down 1 unit. So d of x, the red one, you can see those changes. G of x only had 1 change. I had this plus 2 in the parentheses. That's the only thing that's different from my original function. That's going to be shifting it to the left 2 units. H of x, that's the orange one, has 2 things going on. I've got this multiplication of 1/4. It's a vertical compression by a factor of 1/4. My slope is becoming less steep. I also have this plus 2 hanging on the end. That's a vertical translation up 2 units. And then the last one, m of x, is the blue one on the graph. I've got 2 things going on right here. It's technically 3, but it's 2 numbers that you see in your equation right here. The -7 is a horizontal compression by a factor of 7, but because it's negative, you're also reflecting across the y-axis. This -3 inside the parentheses tells me I'm moving to the right 3 units. If you want more on this topic, please check out the Learning Target spreadsheet for additional resources, videos, and practice.